we're starting off with binary operations. Binary operations deal with two elements, and they give you like a code. So this will be the element here, A star B, and the code will be 3A plus B. So anything on the left would represent A, and anything on the right would represent B. And so you would just stick it in the code given. So for instance, it tells you that if you have A star B, wherever A is, you multiply it by 3, and then you just add whatever B is being represented as, like a form of substitution, right? Like a form of substitution. So we're gonna say 3 times 4, and for you, if you don't get it yet, you can say this is A and this is B, okay? And it tells us wherever A is, whatever is being represented as A, stick it right behind 3. So once you have a number and a letter stuck together, it's telling you multiplication. And we can use our old faithful brackets, and it tells us operation here is to add. And then 6 must be B. So we're going to work out what's inside the brackets first. 3 times 4 is 12. Plus 6, 6, 7, 8. Answer is 18. Okay. Okay, using the same thing here, the same operation they want you to carry out, we're going to use it for this. And we can label again A, B. So wherever A is, we're going to multiply it by 3. So instead 3 times 6 plus 4. 3 times 6 is 18, and we're going to add 4. And that will give us 22, because 8 plus 4 is 12. Carry the 1, you get 22. Okay. And again, we're going to put A, B. And remember, the operation is 3A plus B. That is the operation. So we're going to say 3 times 6 plus 2. And so 18 plus 2 is equal to 20. Okay? So we should have all of that. So if you look at it, well, let's keep going. Here we have 4 by 6. So the operation is 3A plus B, right? So we're going to work out in here first, right? Work out in here first. So this in the beginning will be our A and our B. So let's work out in here first, because remember, we have PEMDAS. Or some people know it as BEMDAS. And that's just the order of operations. So PEM, parentheses, B stands for brackets, E is exponents, M multiplication, D division, A addition, S subtraction. Same order, just the P and the D are different. Okay, so we're going to work out what's in the brackets first. So it says, you want to say 3 times 4 plus 6. So we're working out whatever is in the brackets first. And that will give us 12 plus 6. And that together will be 18. Star 2. Now we have a new A and a B. And whatever it is, we do it again. So we're going to say 3 times 18 plus 2. And we said 3 times 18. If you don't have a calculator, you can work it out on this side. 3 times 8 is 24. And 3 plus 2 is 54. 5. 3 plus 2 is 5. So we get altogether 54, right? So let's say 54 plus 2. And that will give us 56. And then now we're using this one now. So the placement of the brackets has changed. So in this case, we have the brackets in front here. All the numbers are the same, but the brackets have changed. So we're going to look at this again. We're going to do the brackets first. A plus B, AB, sorry. And we're going to say 3 times 6 plus 2. And that will give us 18 plus 2. And that in turn is equal to 20. So now we have 4 star 20. And now this is our AB. We're going to say 3 times 4 plus 20. 3 times 4 is 12 plus 20. That will give us 32. We don't know, is it 20 plus 12? 2 comes on 3, and that will give us 32. Okay, so 2 things to note. They have the same numbers here. There's something called commutative and associative. Commutative means the order does not matter. For instance, if you have 3 times 5 is equal to 15. Same as if you have 5 times 3, that's also equal to 15. So this is called commutative. Okay? And that is, this simply means the order in which the elements are placed does not matter. In other words, it's going to give the same answer, right? So things are commutative if you could turn them around, switch them around, and get the same answer. This is also commutative. 3 plus 5 is equal to 8, as well as 5 plus 3 is equal to, you guessed it, 8. So that's commutative. If you look at this A1 and A2, you realize they have the same number, but they're just the same numbers, but they're just switched around. So the 4 is on the left in this one, and the 4 is on the right in this one, and vice versa with the 6. So, however, when we switch the positions of the numbers, you realize that the answers are different. So therefore, these two are not commutative. Okay? Now, there was another one, 6 by 2, but no, okay. No, that was just a practice question after these two. After these two up here. This was just to make sure you got it. Now, here we have somewhere where we have the same numbers. If you look at it, we have the same numbers, 462, 462, but the placement of the brackets have changed. And when it comes to dealing with brackets, placement of the brackets, you call it associative. So the placement of the brackets, right? For instance, if you have 3 plus 5 plus 2, right? And I put brackets here. Now we have 8 plus 2. And that should give us 10. Suppose we have again 3 plus 5 plus 2. And I place the brackets here. Now we have 3 plus 7. And that gives us 10. If you note, I worked out the bracket, right? So in this case with associative, the placement of the brackets does not matter. However, when it comes to binary operations, if you look at it, the brackets were moved around. So in this case it was around 4 and 6, and in this case around 6 and 2. But in both cases the answers were different. You had 56 and you had 32. So therefore these two are not associative. Okay? So when a question asks you if something is associative or commutative, commutative deals with order in terms of if I usually deal with these operations, multiplication and addition. If I have two numbers and I switch them around using a multiplication sign, will I get the same answer? If yes, then it is commutative. If I use an addition sign and I switch the numbers around when I start to add, am I going to get the same answer? If yes, then your formation is commutative. Associative deals with brackets. For instance, if I'm adding numbers and I put the brackets around a set of numbers, two numbers, am I going to get the same answer if I move the brackets and put around a different set of numbers? And if yes, then your calculations then are associative. Sorry, the formulas or the setups are associative. In this case, we have the binary operations here. When we move the brackets again, we did not get the same answers. Because we did not get the same answer, we said that operations are not associative. I hope this helped. Oh, here we have some more. I actually didn't realize. But now we have P star Q equals to P squared plus Q squared. And here we're asking, are the pairs commutative or associative? So we want to know. So I gave you examples before. So what you could do along with me is try to work out these things. And I'm gonna telepathically try to listen to you, you know, because I'm that good. And I'm going to listen to you and do it at the same time, and let's see what we get. Right, you're correct. So this is representing P and this is representing Q. Wow, you're going good. And so the operation is P squared plus Q squared. So since this is representing P, we're going to say 2 squared, and we're going to add and say 3 squared. Yeah, you're going good. Correct. 4 plus 9. Awesome. And that will give us, correct, you're correct again, 13. And here we have this one. And remember, we put our things here, P and Q. Correct, you're going good. And because we have P and Q, we're going to say 3 squared plus 2 squared. And in this case, what are we going to get? We're going to get 9 plus 4. Correct? And we got the same answer. So in this case, when we use this operation here, right, on the other side, what did we use? On the other side, we used 3a plus b. We had a multiplication and addition mixed up in there. Correct? And in this case, we just squared whatever numbers were over here. And we ended up getting the same answer. So we can say, we can conclude that this is commutative because there are no brackets present. So therefore, this is commutative. And it's commutative because we switch the order. We put the 2 in front of the 3 for the second time, for the second one, and we got the same answer in both cases. Okay, so now we're going to try this one. This one has brackets in it, so we're looking at the word associative. Okay, and we're going to see if this is associative. So what we're going to do first, we're going to look at this and look at what's in the brackets first. So we're going to label this as P and label this as Q. So you're going to say 2 squared plus 3 squared. And we worked this out already. And we know that this will give us an answer of 13. We did it over here. Remember? And now that we have 13, we're going to say 13 star 4. And we're going to put P squared and Q. Sorry, we're going to put P and Q. Great, you're doing well. At this time, we all know it's not too easy to work out the square of 13. So we're going to write it out. 13 squared plus 4 squared. And 13 squared, I think, is 169. Yep, 169. 169, and 4 squared is, correct, 16. We add those two, and we get 185. Okay? Now, let's see if removing the brackets or moving the brackets around the other two numbers, we're going to get the same answer. Let's see if we get the same answer. So we're going to say here, 3 squared plus 4 squared will give us 9 plus 16. And that 9 plus 16 is 25. So we have 25 here, star 2. And this is our P, and this is our Q. So we're going to say 2 squared plus 25 squared. And we're going to get 4 plus, I think this is 625. So already we know that this is not associative. Let's just make sure 25 squared is 625. Right, 625, great. So if we add now, we get 629. Is this associative? No, it's not. It's not. Okay, wait. Not associative. All right. So I hope this helps. I'm going to try to bring our open shot, a bigger shot. Okay, so here we have everything. Okay, great. And on the next page, just to look back. Great. Have everything in there. Are we satisfied? Great. Peace, peeps. I hope you keep up with me. Episode 4 should be coming shortly. Wishing you all the best for the new year. Happy 2019. Just write it here because everybody deserves happiness. Don't ever sell yourself short. Love, Miss